Hello students, in the last lecture I discussed about Geiger-Müller tube, that is a method of detection and measurement of nuclear radiations. In this lecture I am going to discuss another method of detecting and measuring nuclear radiations, that is scintillation counter. So the scintillation counter, it is based on the principle of scintillation. So what is this scintillation? Scintillation, basically what happens, there are certain crystals such as zinc sulfide, sodium iodide, anthracene, naphthalene, etc. So there are certain crystals which produce a flash of light when any nuclear radiation like alpha, beta or gamma particles strike them. So when these crystals are struck by any of the nuclear radiations, a flash of light is produced. So this production of flash of light by the crystals when they are struck by the nuclear radiations like alpha, beta or gamma rays, this process is called scintillation. So the scintillation counter is based on this principle scintillation. So let me discuss the construction here. So we have this for scintillation counter, we have this crystal that produces a flash of light when the nuclear radiation strikes them. So when the nuclear radiation strikes this crystal, a flash of light is produced, this tiny flash of light. Now I've already discussed the photomultiplier tube in my previous lectures. So what was the role of photomultiplier tube? They are used for amplifying the light and they convert it into the electrical energy, into the current form. So here also what will happen, this whole construction of scintillation detector includes a photomultiplier tube also. So whenever the radiation or the light radiation or whenever the nuclear radiation strikes this crystal that produces the scintillation, strikes this crystal, a flash of light is produced, that is tiny flash of light is produced, and this flash of light is amplified by this photomultiplier tube, which is incorporated in this scintillation counter. So this photomultiplier tube is incorporated in the scintillation counter. Therefore each particle that produces a pulse of therefore each particle, whenever it strikes the crystal, it produces a flash of light, and that flash of light is amplified by the photomultiplier tube and therefore produces a pulse of anode current at the output of the photomultiplier. So the output of photomultiplier is applied to a high speed electronic counter which counts each tiny pulse that is generated by scintillation crystals on being struck by the nuclear radiations. And therefore by counting the number of pulses in a given period of time, this scintillation counter can be used for detecting the intensity of radiation. So as each particle will produce a flash of light that is amplified by photomultiplier tube and a pulse of anode will get generated, which is measured by this counter. In this way the number of particles that will strike the crystal going to produce the number of anode pulses, and that is being measured by the counter. So in this way the scintillation counter can detect the intensity of radiation by counting the number of pulses in a given period of time. Now what are the advantages of scintillation counter? So the first advantage of scintillation counter over Geiger-Müller tube is that it is more sensitive than Geiger-Müller tube and it can detect lower levels of radiation. Second thing, these crystals not only produce flash of light upon being struck by the nuclear radiations, but it also produce a flash of light when struck by X-rays. Hence, this transducer, this scintillation counter may be used to detect X-rays as well. And the last advantage is the counting rate is very fast, that is pulses of as short as duration of 2 nanoseconds may easily be recorded by these detectors. So this was all about scintillation counters or scintillation detectors. So I'm ending this class here. So till now we have studied about the types of nuclear radiations and the two methods, that is Geiger-Müller tube and scintillation detector, for detecting and measuring this nuclear radiations. Thank you.